here would be an example of a device that might be duty cycle controlled. Now, I guess you could say this is like an injector, in that fuel pressure would come in here. Here's the pintle that would move to allow the fuel pressure to go past it and then spray out the end of the injector. Most injectors, the fuel comes in the top and goes around and then sprays out, but same idea in terms of you got a pintle that's allowing some type of fluid or air through. So this could be a solenoid that allows vacuum through. In the case of a purge solenoid for an evap system, or a vent solenoid allows air through. EGR solenoid might allow vacuum through to control an EGR valve, or it could be direct control where exhaust gases are flowing through there. It could be idle control. You know, lots of different devices controlled this way. Or it could be that this, instead of being a pintle, this is linked to some type of mechanical linkage like a door lock solenoid. Of course, a door lock solenoid, you're not going to duty cycle control. It's going to be on or off. But anyway, just to give you an idea, a lot of things are controlled with solenoid type devices, and many of them are duty cycle controlled. Now, we discussed ground side control. And this is representing here the coil of wire that turns into a magnet and then pulls the pintle open to allow, you know, the air, the fuel, whatever it might be, through there. This coil of wire needs to turn into an electromagnet to pull that pintle back, and that's going to be done by flowing current through it, of course. I can have battery plus up here, and then ground side being controlled, you know, as we've demonstrated already. You know, the opposite can also be true, and occasionally we do see where it is the opposite, meaning what I mean by saying the opposite, that this side is grounded all the time instead of being battery plus, and instead of pulsing it to ground, it pulses it to battery plus. So, you know, sometimes it is that way, but we're going to use the ground side controlled one for now because that tends to be a more popular way of doing it. So we're going to go with battery plus up here and ground down there, pulsing it to ground. So now back to this discussion about duty cycle. When something is duty cycled, you know, and we talked about that kind of that square wave look, because it's turned on, grounded, and then back off when it's ungrounded, then on again when it's grounded, and then back off again when it's ungrounded. You know, 12 volts up here, 0 volts down there. You might think that this pintle in here would be dithering back and forth as this is turned on and then off and then on and then off. But remember what I said earlier. This is done fast enough that the magnetic field never has time to collapse. So that's why we don't get a voltage spike here like we do on an injector. And whereas an injector, we want it to open fully and then close fully. If we're controlling, say, like EGR, we want this thing to open partially. There may be times where we want it fully open. There's certainly going to be times we want it fully closed, but there's many times where we want it in between. We want it open 10%, we want it open 20%, we want it open 80%. And by controlling how long each pulse is turned on, and I'm going to redraw this, but by controlling how long it's turned on every time it's pulsed, we can control how far this pintle opens. And that's what we mean by duty cycle control. So I am going to redraw what we had earlier, the square wave, 128 hertz. The frequency on a duty cycle controlled device is constant. Frequency, the hertz, is a constant. That's why we don't measure injectors in duty cycle. Now, some of the tuners do, but if you measure an injector in duty cycle, it's going to be at a constant RPM. That's the reason you can't measure injectors really in duty cycle, is because it has to be a constant frequency, and the frequency's always changing. You know, the RPM's changing, the injector's being pulsed at a different frequency. Therefore, that's why we measure injectors in pulse width and other devices in duty cycle. And again, if someone does measure an injector in duty cycle, it can be done, but it's going to be at, it's going to be 80% duty cycle at 4,000 RPM. It will be given at a certain RPM. So let's take a look at like this EGR solenoid, let's say. Let's say that's an EGR solenoid. If I want this thing to be controlled partially open, let's say I want it to be 50%, halfway open, then my duty cycle command will be, it's going to be 128 times per second. Now it doesn't have to be 128, that just happens to be a typical one, 128 hertz. It's going to be on, and then off, and then on, and then off. And when I'm trying to draw here, although it may not be perfect, I'm trying to draw a 50% duty cycle. 50% duty cycle means that it's on for half of the time and off for half of the time. On for half of the time, off for half of the time. It's still pulsed 128 times per second. That's a constant, but every time it's pulsed, how long is it turned on versus how long is it turned off? That's what duty cycle is. Now let me give you another example of let's do a 10% duty cycle. Now, it pulses on, but it only stays on for a short period of time, and then it's off for a long period of time. Then on again, 10%, off again. I suppose I should have drawn this that it lined right up, but you get the idea. 10% on, 90% off. 10% on, 90% off. Okay, well, let's draw the opposite. Let's draw this was a 10% duty cycle. Let's draw 90%. Now, coming along at 12 volts, it gets slammed to ground, gets turned on. Now it's going to be on 90, 90, 90%. Okay. Now it's only going to be off for 10. Back on 90, 90, 90, 90%. Back off for 10. Yeah, artwork's crappy. But you get the idea. Now we got 90% on time, 10% off time. This would be a 90% duty cycle. Now remember, this is a ground side controlled device. So when is the circuit on? When the voltage is grounded. If it is a power side control device, remember before I scribbled this off, I had it where we got battery plus possibly being the switch and being grounded all the time. If that's how it is, well, now the activity's happening on the when it's pulsed over to battery plus rather than ground. Well, if that's what's going on, then this is going to be the opposite. 50% duty cycle is not going to look any different because, it's a 50-50 thing. But if it's positive side control, well, now the device is on when the voltage is high and off when the voltage is low. So this same exact waveform could be a 90% duty cycle if it's a positive, or sometimes referred to as a high side control. Positive side control or high side control. If it's high side control, then that's going to be the opposite. Now if that confused you, let me try again. Okay. Clean sheet. This side's ground. This side being pulsed on and off. I'm going to draw it over this way. Being pulsed on and off. Ah, darn it. So used to drawing positive. So used to drawing ground. Let's draw positive instead. Okay. pulse on and off to battery plus. Well, now, you know, I want to see the activity on this device, just like I wanted to see the activity on another one. If I tap into this side, take my scope, you know, reference off of ground, I'm just going to see ground, you know. If I want to see where the action is, I tap into the side that's being switched on and off. So I tap in here, ground my scope lead, the other one here. Okay, now when, you know, if I'll see a waveform. So I see a square wave thing. I'll just draw kind of a 50% duty cycle for this example. Okay, well, when is their current flow through the winding? When this is pulsed over to positive, or when it's open? Well, of course, when it's pulsed over to positive. So if I'm monitoring that, when that switch is closed, what do I see? Well, I see 12 volts. So now it's on when the voltage is high and off when the voltage is low. So on a 50% duty cycle, it wouldn't matter. I don't have to know if it's a ground side control or positive side control device because it's 50-50 anyway. But you get into a waveform that looks like that, well, is that a 10% duty cycle or is it a 90% duty cycle? You have to know if it's positive side or ground side control because it'll be the opposite of each other. Positive side control in this case would make it a 90% duty cycle. Ground side control would make it a 10% duty cycle. Down on this one, we said this is a 90% duty cycle. Well, we said it was ground side control. If it was positive side control, it's a 10% duty cycle. Hopefully that makes sense to you. Duty cycle, okay, constant frequency. The on time varies, but it's pulsed the same amount of times. 100% duty cycle, I guess I didn't say that. 100% duty cycle means it would just be, you know, on all the time. Then it would be flatline. You know, we talked about pulse width, talked about what frequency is, talked about a cycle, what a cycle is, you know, ground side control, positive side control. Hopefully that all makes sense.